Hey everyone, I'll be going through in this video about the compose matrix. Have you ever wondered that the composable functions we are writing in our project is actually stable, or do we need to optimize how the behavior will be to the end user and how smooth it is and can it be improved? So there are certain questions that I have just highlighted. I'll be highlighting the solutions, how to um, measure the metrics, all the things in this video. So stay tuned. The topic of this video is compose matrix. In this topic, I'll be completely focusing on the matrix of any composable that we write in our project. There are two basic terms are restartable and skippable composable. These terms are provided by Jetpack Compose compiler. We'll be highlighting on this and how these things improve the performance or application, RUI, rendering and smoothness. We'll be focusing on that. So the basic problem is that we write our composable function, we build a project, we ship on the Play Store, but we never know that how many times our composable is getting composed. Do we need to optimize it? Because as an end user, we don't see any much difference in UI rendering or smoothness when it comes to seeing in some end user device. So, but what about the once we try to quantify things, we can see some differences that oh, this composable can be a little optimized, and we don't know which function need to optimize, which composable is causing the problem, right? In composable function, sometimes we create atomic UI, sometimes we reuse some composable function in some other screen. It happens a lot in throughout the UI code because we focus on reusability of the code, and we don't have any visibility that which particular uh, what is the compose compiler decision, how it is deciding that which needs to optimize, which composable function is good, working as perfect, and how it is really impacting the performance of our application. Correct. So here we go. The solution is that compose matrix. Since Jetpack Compose 2.1.2.0 introduced compiler metrics to analyze your composable, now we have the power that Jetpack Compose compiler itself tells us which composable function we need to optimize and which is going good. So what all the things it tells? It tells overall stats. What's the count of composable? As I mentioned, there are two terms, restartable and skippable. What's the ratio? And it give detailed breakdown of all the things what we need to optimize and why is something is getting recomposed more than the suffice time that we need. Lot of things along with that, it provides some CSV file, maybe spreadsheet we can import in our Excel or somewhere to analyze the behavior, what things need to optimize, like that. So this is the basic code that we can add in our projects root level folder or maybe in app level folder. If you are following multi-module architecture, then probably you can add this particular code block in our particular sub module to check the behavior. Maybe in our multi-module architecture, we have multiple folders, something from domain layer, data layer, maybe something of utility, some library. Most of the places we no need to add this particular code because our composable function persists only in that feature level, maybe UI level in your project. So in that particular sub module, we can add this particular code block. For the example that I have shown on the screen is basically for the root level. Here you can see whenever we will assemble our project, in that case this particular block will run. So I'll be showing in the our Android Studio project as well how to edit and how to run and see the result. So before going deeper in the detailed explanation and theory, let's go and see the code. So this is my some pet project maybe that I have created, and this is in this project it has a lot of code, right? Lot of composable function and all. This going to be a good project to give an example for this composable matrix. I'll be clearing it first. I'm cleaning it. It's done super fast. Now if we see in the app module, there is no build folder. What will happen once I will generate the build folder? Inside the build folder we can see the matrix folder and we can check it out. So let's see. So this is my root level build.gradle.kts folder. Here if you see, I have added my that particular code snippet that I have shown earlier. In this I have mentioned that whenever we some compiler will run, it will check this particular property. Here also the could be, sorry, yeah, also they could be anything. You can write your name, you can write anything. Basically this is as per you. This is the indicator that if that particular indicator will be run from the terminal, in that case this particular block will be executed, right? So here we can see this is the absolute path our project. Inside that path, one more folder will be created, compose underscore matrix. In this particular folder, all the files, all the matrices will be contained. Similarly here as well. Fine. So as of now we can see there is no build folder. I will go and run it. So first I will clear all the things. Sorry. So this is the command I have written. Here you can see in the first place Gradle ew.assemble release. I am assembling the release here. After that what I am doing it, I am running one command, auxiliary dot enable compose compiler reports equal to true. So if I run this command, this particular block will be executed because it is I am running this, so it will become as true. Whenever I will run this command, then only this particular folder will be created, that matrix folder that I have mentioned earlier. I have mentioned it on the condition basis, so it won't be created every time. Whenever we want, we can run this particular command and it will get created. You can write as per your convenience. And then we are running rerun task. So again back to terminal, I will run this command. You can see live how it's getting created. Cool. It won't take much time. See, create build folder got created. If I open it, you can see one compose matrix folder. Great, it's done already. I'll open this. We can see four folders here. App release classes. This is all the classes that we have in our project. Probably it's, we can go and check this, but it's none of our use. We can ignore this simply, and we can see the CSV file as I have mentioned earlier. If I relook again in the folder here in the code base, so I have mentioned that this particular code block created report text and CSV, right? That it has created. This is text and this is CSV. Both the things we can see, composable.csv, composable.txt. So for our purpose, without any importing, we can see the txt file and understand how it has gone. So for example, this is pill image viewer. I have created this particular composable function. I won't go in the code level, but we can understand it takes two parameter, image URI and on dismiss callback function, lambda function maybe. So this is restartable, skippable. So we have to see two particular key here, restartable and skippable. Restartable is something that I'm going to explain next, and skippable as well. I will check out some more maybe. Yeah, this is good. Bottom tab view. Here we can see two parameters are there, tab bar items and nap control. Both are unstable. So they are stable, they are unstable. Restartable, skippable, there are certain keywords that we have to talk about in the same series after some time. Let's check out some more. See, here we have some combination of two keywords. Caregiver dashboard screen. Maybe this is the first composable of my particular screen. So this particular composable parameter view model is unstable, and another one on navigation is this could be lambda function. This is stable. Similarly, we can see all our methods, all our composable functions that we kept throughout the project is restartable, skippable or not. So we can see mostly all having the stable parameter. Whatever is not, what we can improve, that we can discuss maybe later. Okay, cool. I think we are good. We can go through once you are following the same step. You can go through this kind of things. We can see how many skippable, restartable, all the metrics we can see. Please hit up. Please comment below if you need me to explain a lot more about these kind of things, how we can analyze the performance and all. Please drop a comment. Okay, now back to our deck. Cool. So now we have seen that how this particular code snippet work and how it helps us with the metrics to how to create the maybe the how to say the metrics report to see our composable performance. Now what is restartable that I will talk about here. Restartable function is a recomposition scope that we can see on the screen. What happens actually restartable is kind of same as recomposition that we all are aware. It means that when some input will change in our composable function, it will re-invoke itself. Correct? Now the second term is skippable. What is skippable and how it is different from the restartable? Skippable, basically we call it smart optimization. Skippable means skip as much as possible. Whenever possible, just skip it. Maybe we have a composable function, and when it will recompose, when something will change, when any composable function, maybe our composable function that we are highlighting is b, parent is a, b is inside a. So when A will recompose, B will also recompose. That is called restartable. B composable function is restartable. But do we really need to recompose the B? If answer is yes, it is fine. If it is no, then we no need to recompose it again. How can we control as a developer? Here, there are a lot of concepts come stable, unstable, annotations and all that we have seen in the metrics report. Here we can see how to do compose checks. First of all, if something is restartable, something is skippable, it means it should recreate only if parameter got changed. It should not recreate itself every time when the previous or the parent recompose itself. If it nothing got changed in the parameter, as I have shown you in the matrix report, some parameter was stable, some parameter was unstable. If it is stable, then whenever it change, it will recompose itself. If it is unstable, no matter something get changed or not, it will recompose itself always. And how this is how we can optimize our particular composable function performance. So there are two terms we can see, restartable and skippable from this slide. Now we are comparing restartable and skippable. It's clear picture now you would be having that what is restartable. Basically it composes itself when something gets changed. What about restartable plus skippable? So it's certain boundary that how many times I need to recompose myself. Is there any certain boundary? Yes, we can keep stable parameter in particular composable, so it will not recreate itself, it will not recompose itself all the time. If something got changed in the parameter, the value got changed of the r parameter, then only it will recompose itself. This is how we optimize the performance. Now there are two concepts of stability: immutable or stable. Immutable means maybe if the parameter value is not going to change at all, then we call it immutable. And stable means we can annotate. Let's say there is a composable function user profile. In that user profile we are passing one parameter called user. In the user there are maybe some parameter in that model class: name, age, and mobile number. All the three things will be changed by the time once we switch user by user, maybe like that. If we annotate that particular data class as stable, it means user profile composable function will be recreate itself whenever any change will happen in these particular three keys possessed in the user data class. Now main thing is that how to read those matrix file that I have shown. So I have slightly explained what is there in that file, how to read it, how to decide which particular computer we have to focus on, right? What is which needs some effort, which is good to go, which we can ignore. So the third line, if you see, restartable but not skippable, there are certain things that it's restartable but not skippable. Your any composable function should be skippable. It means that if it should not unnecessarily recompose itself, then we have to, if it is restartable not skippable, then we have to check why it is not skippable. Is there all the parameter available in this particular composable are unstable, or is there something we can make it stable? And what is the type of unstable, right? Is it really unstable, or we can somehow make it stable? That will improve our performance, making that particular composable function skippable. Cool. Now back to action plan. If you like this video, maybe probably you will go and check out the same thing and implement in your code base to enhance the performance of your composable function. So first of all, we have to add that code snippet that I have just shown in the slide and the code base as well. We have to put in our root level, maybe in our you can add at your submodule wherever you have mentioned your particular composable function. Then there are two things basically: debug and release. Better if you change the build variant to release and run this particular report, you will get better performance. And with one more suggestion, run this on your real device. You will see the difference after optimizing and all. Cool. Now, what's the common problems we have, and how we should be very what do you say, sincere about while doing these kind of things? Reading metrics from debug build, we should not. As I mentioned, we should always trust on release. After we get the report, we should not be over optimizing this. We should not add that is stable maybe annotation everywhere. And the last thing is that we need to test it on real device. Cool. These are key takeaways I'll be go through. So what is restartable? Now we have to be clear till this moment what is restartable and what is skippable. I mentioned it green. It means it is green flag. It is good thing, positive thing, and how we can make our composable skippable so it will enhance our composable performance. Cool. And now there are certain things you might be thinking that what is how we can make our composable data class or something stable or unstable. What's the example of it? So you can check my medium blog. I have written certain a lot of things in which I have published that in my, hold on, cool, this one. I'll be adding this link of this blog in comment section. Maybe you can go and refer. Here I have mentioned various ways to check out if particular composable is stable, unstable, and how to make it, and what the code snippet we can look for to decide it is stable or unstable. There are a lot of things I have mentioned in this blog. This is very going to be very big blog. Maybe you can check out and go through. Please post your comment if you want me to create more videos like this and dig deeper in the report section. I think this is what I wanted to share as part of this video. Thank you. Stay tuned, and I'll be back to slide. Okay, thank you. Thank you for joining me.